So we're going to be moving on to our next participant, whose name is Maya. Maya, if you could join the screen. All right, I see you're joining. That's awesome. All right, I'm going to leave it to you. Good luck.
Okay, thank you. Well, understanding how a planet has changed through time is a cornerstone motivation for the exploration of space. The recent arrival of the Perseverance rover has made possible a new era of in situ or in-place sample collection, where we have the opportunity to collect Martian rocks directly from outcrop. While Perseverance's objectives are to look for signs of life and collect samples from the ancient Delta and Jezero crater, the technological advancements of the Mars sample return missions have created the opportunity to one day build a database of Martian rock ages with known stratigraphic context. With this context, we can better understand the distribution of rock ages on Mars, and if found, constrain the ages of ancient Martian life. We know that zircons are present on Mars from meteorite evidence, and the collection and return of zircon-rich samples is an efficient way of gathering a large set of ages with limited sampling. My master's research focuses on the application of detrital zircon geochronology to constrain the timing of events that shaped Western Newfoundland 600 million years ago. Detrital zircon geochronology works by analyzing a large number of tiny zircon grains, which are around the same width as a human hair, and are most often collected from sandstone units. Zircons are long-lived, resistant minerals that act as clocks for when they were formed. Since zircons are so resistant, they can be transported intact over large distances. This means that within a sedimentary unit, we can have many different ages of zircons preserved. By dating these tiny minerals, we can learn about where the zircon originally formed and the age of the sedimentary unit that hosts them. As the database of zircon ages grows, we can constrain the timing of major events in Mars's geologic history. For instance, the Jezero crater delta likely formed in a similar way to the Mississippi Delta, where large volumes of sediment were deposited at the mouth of the river in the form of lobes. Without age data, the origin of sediment that sourced these lobes is unconstrained. And if we date the material in them, we can determine how large the catchment area for the delta was. Mars has been dated in situ by potassium argon and surface exposure dating by the Curiosity rover, but is most often dated using crater counting interpreted from orbital imagery, which uses the density and relationship between impact craters to estimate the age of the planet's surface. Crater counting has been used to establish a geologic timescale on Mars, and the age it has provided can be further refined when combined with an absolute dating method such as detrital zircon geochronology. Sample return missions for Mars are an opportunity to date zircons collected directly from outcrop and to develop an age database where interpretations of Martian sedimentary origin can be derived. The incorporation of detrital zircon geochronology as a sampling method would be a step towards refining the age of events on the Martian surface, and an efficient sampling method to obtain a larger age data set for a smaller sampling area. Constraining the age of major Martian milestones will give valuable insight into the evolution of the red planet and potentially aid us in our search for evidence of Martian life. Thank you.
Much, Maya. Something that the audience doesn't know is that we actually went through all the rehearsal videos before this, and I remember seeing yours, and this is really fantastic. Like, it was originally very good, but this is also much better. So, good job.
Great, thank you.
Okay, so we'll be moving on finally to our final contestant, Victoria.
Hello, I'm just going to share my screen.